In this lecture, let us talk about multiplexer. The outline of this lecture as follows. First, we will try to understand the multiplexer. How does it work? Next, we will discuss 2x1 multiplexer. After this, we will talk about 4x1 multiplexer. Then we will discuss 8x1 multiplexer, and finally in this lecture, we will design 8x1 multiplexer from 4x1 multiplexer. Okay, now let us talk about multiplexers. Multiplexer is a combinational circuit that select one binary information from many of input and direct that one information to output. Okay, in other hand, we can say that multiplexer has many inputs but one output. Okay, now the question is how to select one input and direct it to the output at a time. It is done with the selection lines. Now let us talk about selection line. What are the selection lines? In fact, next we will see in example how to use and what are the selection lines. In fact, here we will talk about the use of selection line. Okay, if we have 2 raised to power n inputs, then we required n number of selection line. Now the selection line would be the n selection line we will use. Selection lines. Okay, now this figure illustrate. Okay, if suppose you have 4 output, excuse me, if you have 4 inputs 2 raised to power 2, then we need n would be equal to 2, then we need 2 selection line. If you have 8 inputs from D0 to D7, then we need 3 selection line, and further we will see how to use these selection line. This figure shows the block diagram of the multiplexer. Here these are the input data, and then we have enabling input. Later on we will see how to use the enabling input, and here we have the selection lines. These selection lines depends, the output or the selection of this input depend on these selection lines, and this is the output. Okay, now let us talk about a simple multiplexer, 2x1 multiplexer. If we have, suppose if we have 2 inputs, this is the block diagram of the 2x1 multiplexer. We have 2 input and always multiplexer has always one output. Okay, now these let us talk about their applications. These are very useful in communications, wherein at a time we need to send in telecom or somewhere we need to these are useful in switching. They allow the one user or the one information to send at output at a time. Okay, now these are the inputs. Suppose this is D0, this is D1, and this is the output. Now with the help of selection line, we will choose which of the input should be sent to Y. Okay, for this we need only one selection line, which is S0. If S0 is 0, it will allow D0 to output Y. If S0 is equal to 1, it will allow D1 to direct it to output Y. Okay, now let us talk about its truth table. I'm sorry. Okay, this is the selection line, and here is the output. When the selection S0 is equal to 0, it will allow this output D0. And when S0 is equal to 1, this will allow the input D0 to direct to Y or send to Y. Okay, now let us talk about its circuit. Its circuit should be very simple. We need AND gate and here we have a selection line which is S0. Okay, this is the input D0, this is the input D1. Okay, now this selection line will decide which of the input should be direct to output Y. Okay, now if let me use some red line. If we have S0 is equal to 0, it will allow D0 direct to Y, and if S0 is equal to 1, then it will allow D1 to Y. Okay, this is the 2x1 multiplexer. In similar fashion, we can design 4x1 multiplexer. Okay, now let us talk about 4x1 multiplexer. For 4x1 multiplexer, the n should be equal to 2. So we need n number of selection line, we need 2. Okay, now first let us talk about the block diagram of 4x1 multiplexer. We have 4 inputs, 1, 2, 3 and 4. Suppose this is the I0 first input, I1 second input, I2 third input, and I3 is the fourth input, and it has one output which is Y, and I call it 4x1 multiplexer. And how many selection line we are required? We need 2 selection line. Those are S0 and this is S0, this is S1. Okay, now let me construct this 4x1 multiplexer, the combinational circuit. Before combinational circuit, let us talk about its truth table. its truth table should be, these are the selection line, this is the output. When selection lines are 0 0, it will allows this input I naught to direct to the send to the output y. In this case I will get the output y, which is equal to I naught. When we have a combination 0 1, in this case I will get output I1. When we have a combination 1 0, the output would be I2. When the combination is 1 1, the output would be I3. Okay, now we can draw the combinational circuit of this 4x1 multiplexer. For this purpose we need, in similar fashion we did for 2x1 multiplexer, here we need 4 AND gate and 2 selection line. Okay, this is the AND gate, second AND gate, third AND gate, 4 AND gate, and we need a OR gate. This is the OR gate. Now we need a 2 selection line. The selection lines are S1, S0, sorry, okay. Now we have 4 inputs. The inputs are I0, I1, this is I2, and this is I3. Then how to use this selection line? When S0 is equal to 0 and S1 is equal to 0, it will allow I0. So for this purpose let me use the red line. Okay, should connect it to, this is connected with S1 prime, S0 prime. So when both S1 and S0 are equal to 0, then it will allow I0 to direct it to Y. Okay, the output Y would be equal to I0. Now the next case, when S0 is equal to 1 and S1 is equal to 0. So in this case let me use some different color. Okay, S0 is equal to 1 and S1 is and S1 is equal to 0. So this is the case. When then our output would be equal to I1. So next case, S1 is equal to 1 and S0 is equal to 0. So I will connect S1, which is equal to 1, and S0 is equal to 0. So this line is for S0. So for this combination, the output would be equal to I2. I mean, this input would be allowed. Now for last combination, both S1 and S2 are equal to 1, so I will connect this one, and furthermore this line will be connected with this. So in this case, when S1 and S0 is equal to 1, it will allow this input to direct to Y, or in other words, the output Y would be equal to I3. Okay, this is the 4x1 multiplexer. Now let us talk about 8x1 multiplexer. In 8x1 multiplexer, we need 8 inputs, and we have 8 inputs, 1 output. How many number of selection lines we need? For this purpose, 2 raised to power 3 is equal to 8. So we need n would be equal to 3 in this case. So the 3 selection lines are required. Okay, now let me draw the block diagram. Its block diagram is I4, I5, then I6, and I7. So we have 8 inputs and 1 output. Number of selection lines in this case eight inputs and 1 output, and number of selection lines would be 3. Those are S2, S1 and S0. Okay, now let us talk about its truth table. The truth table would be, this is S2, when the combination is 0 0 0, so this multiplexer will select I0. When the combination is 0 0 1, it will select I1. When combination is 0 1 0, it will select I2. When the combination is 0 1 1, it will select I3. For combination 1 0 0, it will select I4. For the combination 1 0 1, it will select I5. When the combination is 1 1 0, it will select I6. When the combination is 1 1 1, it will select I7. Now let us draw its combinational circuit. We need 8 AND gates. Okay, we need AND gates, 8 AND gates. This is 1, this is 2, 3, 4, 5, 6, 7, 8. Okay, now we have 8 AND gate, 2, 3, 4, 5, 6, 7 and 8. Further, we need one OR gate. This is the OR gate. It will give us the output. Then we need to connect these OR gate with this AND gate with this OR gate. 2, let me redraw this OR gate. Okay, now we have 8 inputs. So the inputs I will AND I naught with this AND gate. Okay, now these are the inputs. I will start from I naught. This is I1. This is I2. This is I3. This is I4. This is I5. This is I6. This is I7. Now we have 8 AND gates, so we need 3 selection line. So the selection line okay, let me these are the selection lines. First is S1, S2, this is S1, and this is S0. So these are the selection lines. Now when S2, S3 and when S0, S1, S2 are equal to 0, in that case we will select the input I0. So the output would be equal to I0. Okay, let me use some different wiring now. Okay, this color red I want to select. So this is S2, this is S1, S1 prime, this is S0 prime. So for next combination, when S0 is equal to 1, S1 is equal to 0, S2 is equal to 0, we will select I1. So for this case, I am going to connect this wire with this wire with this. So here S2 is prime and here S1 is prime. The next I have to connect it with S0. Let me choose some different color. Okay, this is the wiring for S0. Okay, for this combination, when S2 is equal to 0, S1 is equal to 0, S0 is equal to 1, so the output would be equal to I1. Next, I will connect S1 with this AND gate and and S1, S0 is prime and S2 is prime. Okay, for this combination, when S2 is equal to 0, S1 is equal to 1, so in this case S1 is equal to 1 and S0 is equal to 0, the output is equal to I2. For next case, S2 is complement, so I will connect this input, this AND gate with S2 prime and S1, here S1 and S0 are equal to 1, so this is S1, this is S0. For next combination, S2 is equal to 1 and S1 and S0 are equal to 0. So okay, let me choose S2 which is equal to 1 and S1 is equal to 0 and S0 is equal to 0. For next combination, S2 is equal to 1 and S1 is equal to 0, S0 is equal to 1. For this case, we will choose this input I5. So for this case, S2 is equal to 1 So I will connect this selection line. Let me use some different color. Okay, here S1 is equal to 0. So this is for S1, and S2 which is equal to 1. I am connecting here, and this one is for S0 which is equal to 1. For next combination, S2 and S1 are equal to 1. So here this is S2, this is for S1, and whereas S0 is equal to 0. Later on I will connect. For final combination for I7, S1, S2 and S0 are equal to 1. So here I will connect this wire, then this wire, okay, this wire, and here this S0 was equal to 0. So this is the combinational circuit for 8x1 multiplexer. Similar fashion, you can design 16x1 multiplexer, 32x1 multiplexer, so that you can, by using this concept, you can design a complicated circuit. Now next let us talk about 8x1 multiplexer that you can design or construct by using 4x1 multiplexer. Okay, now move to, if suppose if in lab or laboratory or somewhere you have available 4x1 multiplexer and you want to design the bigger multiplexer, so you can use, 4x1 multiplexer can be with the help of 4x1 multiplexer you can design a complicated circuit, 8x1 or 16x1 multiplexer. Okay, now let's see this example. Suppose you have a 4x1 multiplexer, to 4x1 multiplexer. Okay, now you have to use, okay, it has one output, 1, 2, 3 and 4 inputs. Similar fashion, 1, 2, 3 and the 4 inputs and 1 output. So okay, let me start from I0. This is I0, this is I1, this is I2, this is I3, this is input I4, this is I5, then I6, then I7. Okay, it has two selection line. Selection lines are and it has two selection line. Okay, we will connect these selection lines. This one is S1, we'll short this selection line, this is S0, these are the outputs. Again we will use some 2x1 multiplexer. So now it has 2 inputs and 1 output. This is the output and it has selection line which is S2. Okay, now when we have S2 is equal to 0, then for S0 and S1 we will use for when S0 is equal to 0 and S1 is equal to 0, it will choose this input. Okay, you let us draw the truth table. S1, S0, and this is the output Y. Okay, in first case, suppose S2 is equal to 0, then it will select this input. So in this case, when S2 is equal to 0, for S0, S1 0, S0 0, the output would be equal to I0. Next combination 0 1, the output would be equal to I1. Then next combination for 0 1 0, the output would be equal to I2. Then for 0 1 1, the output would be equal to I3. Okay, when this S2 is equal to 1, this will allow, this input. Now this multiplexer would be allowed. Okay, for this case, when S2 is equal to 1, for 0 0, S1 is equal to 0, S0 is equal to 0, it will choose I4. One 0 1 would be equal to I5. One 1 0 is I6. 1 1 1, which is will allow input I7. Okay, some other way you can also design this 8x1 multiplexer by using enabling bit. Previously in block diagram we have discussed this multiplexer has some enabling bit. This one is the enabling bit. Okay, now with the use of enabling bit, we can design this 4x1 multiplexer. Okay, instead of using 2x1 multiplexer, here we will use OR gate. So this is the enabling bit. This is the enabling bit. So when this enabling bit, this enabling pin, when this is equal to 0, it will allow this multiplexer, and when it is equal to 1, then this will allow this multiplexer. So this is the alternate way to design 8x1 multiplexer from 4x1 multiplexer. Now in similar fashion you can design 16x1 multiplexer by using two 8x1 multiplexer, and so on. Okay, that's it. It is the end of the section for combinational circuits. Now in next lecture we will talk about sequential circuit. That's it. Thank you very much.